Welcome to Lesson 11, the moment this course stops being a checklist and becomes infrastructure as code. The first 10 lessons taught you what to harden. This one teaches you how to repeat it reliably across one host, 10 hosts, or 1,000. We're moving from bash scripts that drift to Ansible playbooks that converge, agentless over SSH, declarative in YAML, idempotent by design. By the end, you'll own a reusable Dargslan hardening role. You can point at any fresh Ubuntu 24.04 box, and only the inventory changes between your laptop and production. So why Ansible? Why now? You absolutely can wrap lessons 01 through 09 in a bash script, and it'll work beautifully the first time. But by host 200, somebody's hand-edited sudo the script hits an unexpected state, and the whole run breaks. That's drift, and bash has no answer for it. Ansible's answer is idempotence. You declare the desired end state, and the tool figures out what's already correct and what needs changing. Run it once, run it 1,000 times, same result. On the left, imperative steps that shatter on contact with reality. On the right, declarative convergence, parallel SSH, check and diff modes for drift detection, and molecule plus Ansible lint to test the role in CI. And the kicker at the bottom, no agent, no daemon. Just Python and SSH. Both of which Ubuntu 24.04 already ships. So how does Ansible actually wire up to your fleet? 2 YAML files, that's the entire entry point. Inventory describes the hosts, grouped by role, so web, DB, Bastion, each become addressable targets. The playbook says what to apply, and in our case it's one line. Apply the Dargslan hardening role to all hosts. Become root for privileged tasks. Notice the play recap at the bottom. Webs 01 needed 12 changes. Webs 02 was already converged with 0. DBs 01 needed 8. Same command, 3 different starting states, 1 consistent end state. That's idempotence in production, and it scales identically from one host to 1,000. Now let's crack open the role itself. This is standard Ansible layout, but the mapping is what matters. Each file under tasks /corresponds one-to-one with a lesson you've already completed. sh.yml is lesson 1, sudo.yml is lesson 2, all the way down through systemed at lesson 9. Defaults holds your tunable knobs, sh port, allowed users, handlers restart services only when something actually changes, and templates renders sshg config from variables instead of shipping a static file. One directory per concern, and the whole curriculum becomes a single importable role. So here's Lesson 1, Hardening SSH, rewritten as YAML. The template module renders sshg-config.j2 into a drop-in file under sshg-config.d, locks it to root with mode 600, and crucially runs sshd-ta against it before committing. If the syntax is broken, the play fails safe instead of locking you out. The notify line only fires the restart handler when the file actually changes. That's idempotence in practice. Variables like SSH port and SSHR allowed users live in defaults, so the same task hardens one host or 1,000 without edits. That notify line points here to handlers. Think of them as deferred actions that queue up during the play and fire exactly once at the end, and only if something actually changed. So restart SSHG, reload sysctl, reload AppArmor, load audit rules, they all sit dormant until a task notifies them. Run the role 100 times against a converged host, and SSH all never bounces. Underneath, defaults like SSOR port, SSORC allowed Docker users, password, max days give you the knobs to retune per environment. 22 on a workstation. 2222 on a Bastion, same role. Now, before you ever point that role at production, you run it twice. First pass, --check plus --diff against staging. Check predicts what would change without touching the host, and diff shows you the exact line-level delta. Permit root login yes becoming no, right there in your terminal. A human reads that output, signs off, and only then do you run for real against prod inventory. Same playbook, same role, different inventory file. And because Ansible is idempotent, the second run reports changed equals 0. proof the fleet has actually converged. Skip this dance, and you become the production incident. But convergence isn't a one-time event. Hosts drift. Someone SSHs in at 2 a.m. to debug, edits SSHD config just for testing, and forgets to revert. A new EC2 instance spins up outside your playbook flow. So we weaponize that same -- check flag in cron. Every night at 3 a.m., deploybot runs the role across prod inventory, dumps the log, and greps for any changed equals 1 through 9. If the count is non-zero, page on call. And when drift fires, you pivot straight to lesson 08's or search, sudo as ssh config, accounts, to answer who touched what and why. Now, drift detection assumes the role itself is solid. But how do you know it stays solid as you edit it? You treat the role as code because it is code. Every pull request triggers 2 gates in GitHub Actions. Ansible lint scans for syntax and style sins, and Molecule spins up a clean Ubuntu container, applies the role end-to-end, then reruns it to prove idempotence. A clean PR ends with idempotence test passed, 10 assertions pass, and only then can it merge to main. Bad roles die in CI, not in prod. Even with CI in place, scars still happen, so here are 5 that left marks. 1. A strict allow users list shipped, SSHG restarted mid-play, and the whole fleet went dark. Always validate with SSHDT and keep a serial console open. 2. Shell module appending to syscircle.conf forever until the file hit 50 megs. Use line-in file or template, never shell for state. 3. A plain text password in defaults, pushed public, indexed by Google, Ansible Vault every time. 4. Skipping, check on prod and eating 47 surprise changes per host. Dry run gate is non-negotiable. And 5. Forgot become, true, apt silently no opt, and you burn an afternoon debugging. Set become at play level and always read the recap line. With the scars catalogued, let's zoom out on the 6 skills you now own. You know why Ansible, idempotent, agentless, declarative. You can write an inventory and a playbook, lay out a role with tasks, handlers, templates, and defaults, and wire them together so tasks notify handlers and vars live in defaults. You run, check, and diff before every apply, and Molecule plus Ansible lint guard the role on every pull request. Lessons 1 through 9, codified into one reusable role. Next up, Lesson 12, the capstone, a 30-point production checklist and your course graduation. Fleet automation, done. The role is written, idempotent, drift detecting, and CI tested. 4 checkmarks that separate a hobby script from production infrastructure. Lesson 12 is the capstone, a 30-point production readiness checklist, a full cross-course recap, your graduation certificate, and a portfolio template you can show to employers. Then we'll point at what's next: Kubernetes hardening, BSD, eBPF, audit as code. Load the final lesson. I'll see you there.